different ways to find the mean. There are three methods: direct method, assumed mean method, and step deviation method. I'm sure most of you will fall in love with assumed and step deviation because direct method is not easy in quite a few cases. So hope you guys remember class interval deals with the range of things that numbers we are handling. Our class mark is required, which is the average of each of the class. That is, we need to add the lower limit plus the upper limit and divide by 2. So this is 7.5. This is 22.5. And this is 37.5. All this is pre-calculated. I'm just looking at it and writing it. Okay. So don't get scared that should you do so fast. There's a trick. I'll show you the trick. So starting, you have to add and divide, and after that, there is a trick. Okay. Anyways, before I start off, I would like to talk about the representation. So see, when I tell this is xi, this is fi, right? So what does it mean? What does I stand for? Basically, people don't understand what does this I stand for. I is integer numbers, right? Positive integer numbers. So we start with 1, 2, 3, 4, so on and so forth. So the first row will have ones, second row will have twos, third row will have threes, fourth row will have fours. That is, xi in the first row is x1, fi in the first row is f1, xi fi in the first row is x1, f1. For the second row, it is x2, f2. Third row, it is x3, f3, right? So on and so forth. So when someone writes summation of xi, fi, we know summation means sum of what? x1, f1, product of that, second term, third term, so on and so forth. And summation of fi happens to be f1 plus f2 plus f3, so on and so forth, right? So this is your x representation. This you need to understand. So 1 means first row, row 1, row 2, row 3, row 4, right? So I stands for the positive integer numbers representing each row. Try to understand this. No one will ask you anything regarding this, but understand what you're doing. Just don't by heart anything. Next procedure is that you need to find the sum of each of this element. 7.5, there's 17 times that is occurring, right? That's what it means. I hope you guys remember. The product happens to be 1 to 7.5. I used calculator and done it. So see, these are not easy numbers. All these are really tough. Is it not? And find, okay, I found the sum on my own. Finding the sum is also, okay, actually multiplying is a very hectic thing. Taking the sum is not that big deal. Next is finding the mean itself, wherein we are finding the sum of the column divided by the sum of the frequencies, that is 71. And the answer happens to be 21.44-ish. Okay, so this is your answer. This is your direct method. This was not easy. Same set of data, I'll use something else. Here, I'm going to use something called as assumed mean. That is, I'm going to assume a particular number to be the mean, and I'm going to subtract xi with that. For example, di is xi minus a, where a is, I'll take 7.5. I'll assume that to be the mean. So basically, what I'm going to do here is I'm going to subtract xi, right? I'll write what I'm going to do here. Basically, each row I'm going to subtract x1 minus a, x2 minus a, x3 minus a. That is, I take up xi value, class mark value, and going to subtract with a particular number. So difference is 0. Here the difference is 15. Here the difference is 30. And post this, I'm going to multiply xi di. That is x1 into d1, x2 into d2, x3 into d3. 0 into simple 17 is 0. 15 into this is 30. 60, 630. This is 240. No, wait. 360. 990 is your sum. So this is the math. Simple. We need to find the sum of, not my bad, this is not x. This is fi into di. We need to find the sum of fi di, right? That's what the formula dictates. Divide with 71 and add with a. So let me substitute a value. A value happens to be 7.5, right? How did I take the a value? I took the a value, which is very convenient. That is, I took a value from xi, which when I subtract with that particular number, most of the cases, you will get whole numbers over here, which is much easier to handle. And then we have 990 by fi, that is 71, right? Okay, so now we just need to do this math. So let me show you this. 990 divided by 71 plus 7.5. As you can see, we got the same exact answer, 21.44, approximate 21.44, right? We got the same answer, same mean. All we did was we assumed a number to be the mean, subtracted with that particular number, okay? And then we handle with fi and di's, right? This is much, I literally multiplied this on my own. I didn't use calculator. It's much easier, right? And post that, you have a small set of formula, that is, you need to add the last row, add the frequency, like, like the direct method, divide those two. But additionally, since we subtracted a particular number, we're going to add it back. So when we add it back, we'll get the mean. That's why it's called as assumed mean method. We assumed a number to be the mean, and we have ease the calculation. Now, if you find assumed mean to be a bit tougher, because you have to multiply with 15 and 30 and stuff. Say you get some other number like maybe 17 and 34 and things like that. Even then it's difficult, is it not? Right? So here we got 0, 15 and 30 by taking a to be 7.5. So the next method is known as step deviation method, wherein we'll further ease the process. How can we ease it? Again, look at di. What do you see? We see that there are numbers which has a common factor. They have common factors. The HCF between all of these numbers, all di, is taken as h. And we call another column ui, which does this. That is, we're going to divide di with that particular value of particular HCF value. So basically here the HCF happens to be 15, right? I'm going to divide di with all of this. I'm going to divide all the values of di with 15. So 0 by 15 is 0, 15 by 1 is 1, and 30 by 15 is 2. And the last procedure is we're going to multiply ui with fi. So this is your fi, this is your xi. So 17 into 0 is 0, this is 42, and this is 24. So the sum is 66. Make sense? And now we're going to make use of the formula x bar is equal to, so as usual, we should add up your ui's. So summation of ui fi divide with summation of fi. Same thing, 71. What is the previous step? What did we do? We divided with h, so we'll multiply with h. What is that previous we did? We subtracted with a, we'll add a. And this is your formula. As simple as that. If you understand the mean formula, right, which looks like this. Other methods, it's just a matter of going one step back. Whatever you're doing, just go one step back, you'll get the formula. So this is 7.5 into 15 into 66 by 71. 66 into 15 happens to be, sorry, this is addition, happens to be what? 990. 990 by 71 plus 7.5 is same as this. So we got the same answer. Can you see that? This is your third method, right? So again, I'll repeat. Direct method is good when we have numbers which is easy to multiply, right? And don't forget the representation. Xi, Fi, Xi, Fi, all of this means I stands for the positive integers depending on the number of, the row which we are standing in. Xi will take that number. So in fourth row, it will take X4 and F4, and the product will be X4, F4, right? So it's the same with Di and Ui and everything. So assume mean method is, direct method is not too easy with such weird numbers. We need to use calculator, which is not possible in your exams. So we go one step. We assume a number to be the mean. You subtract with that with the class mark. The difference is what you're going to handle as mu xi, wherein we are multiplying with fi's and so on and so forth. That's your assumed mean method. Third one is step deviation method, wherein you feel that this di is not easy to again multiply. We can go a step further. Take the factor. Most of the cases you will get a common factor. Pakka. You need not worry. So you get that factor and you divide with that, and then the same procedure, UIFI, and find the sum and so on and so forth. So all these three methods, they are derived from, it's an extension of the basic idea, that is summation of all the values divided by the number of values. It's the same idea. From that we have direct method, step deviation method, and assumed mean method. Okay, actually I wrote it ulta. This is assumed mean, and this is step deviation. Right? You can see it's the same pattern formula. It's the same pattern. It's just a step extra to ease the calculation. That's it.